Now what I wanted to show was, you see those little blips on top going boom, 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 boom. Those coils, they want to resonate with the near field magnetic effect coming back. There's an echo coming back magnetically across the coils. So you inject resonance in, and then the field around that wants to then reflect back to the coils, and that's what you see there. Boom, 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 boom. And these are sine waves. Let me show you. They're very nice sine waves. They have a jitter to them, and that jitter is sitting on top there. And then you can see the harmonics on the screen and inside the wave. So these coils, these two coils, I will show you. These two guys right here. They're very close. Number 3 and number 4. There's a green one inside of there, if you can see it, just down inside there. Right there. We're looking at it right there. That's 13 megahertz inside there. These two guys here are 7.9 megahertz. The red ones are. So I'm driving this one and I'm reading this one. I get, see, over on this guy, I'm correct. Over on this guy here, you can see this wave. There's a jitter in there, but there's 7.9 megahertz. That's because I'm driving an equal coil. I'm driving a coil that's equal with the coil that I'm reading. When I drive number 4 and I read the green one inside at the 13 megahertz, then this scope shot shows up 20 megahertz. Additive of the 7 and the 13. Give or take a few hundred hertz. I don't know if you can see, that's pretty blurry, but I mean, you can see the waves. Maybe you can see them jittering. So they're very close. So you get two very close waves, and when they heterodyne at the max, I get like a 21 volt jump. There, boom. Normally they're both like 15 volts, but they every so often they sync up. And I'm reading the second, this is the number 3 coil off of B right there. This guy right there. So those are very, very close in length. Length only. If you want a different ratio, you just change the windings. That's all. But it's length. So now what I'm going to do next is try to find what length the green one is inside compared to these guys. Because like I said, these are 7 or 8, 7.9, and the green one is 13 megahertz. That's its natural frequency. So when I drive number 4 and I read the green, that's over on the isolated scope. I read the 20 megahertz. It's additive. It's close enough. And the waveform is a heterodyned waveform of the two. You can see the 8 and the 13 and superimposed on each other, and then you can see the tall spikes coming through up to 20 volts. And every so often this one will give you a 21 volt. But guaranteed, when I drive the two different coils, the two different lengths, 4 and the green one, I definitely over there get a major difference on the scope display. So that's where I'm heading to now. So what I want to do is I want to keep driving number 4, but I'm going to add some wire length to the green one to see if I can match up to the length of this one, to see if I can get the frequencies the same. That'll be a key indication of the self-tuning capability of these devices. That's it for this one. Later. Giant Killer over and out.